If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Good evening, everybody, and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and darn good friends of York University. I'll be one of your three hosts this evening. My name is Paul Delaney, joined by the incomparable Sarah. Hi, Sarah.
Hi, everyone.
Not to mention the Mr. Ever-Ready Eddie, Shatish. Hi there, Shatish.
Hello. Hi, everyone.
We are broadcasting live from the York University Astronomical Observatory located in Toronto, Ontario, Canada. And of course, we are leading off the Astronomy Night in Canada, where the lineup is entirely Canadian, starting with ourselves, York Universe, then on to Western Worlds, Universe Today, Astronomy Cast, Quirks and Quarks, not to mention Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, which of course is Tuesday morning at this time of the year, 1 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. And of course, it runs between the hours of 9 and 10 o'clock here in Toronto. By all means, point your favorite web browser to observatory.info.yorku.ca. Join the chat room. There's all sorts of questions that fly around there. The Observatory team will do their very best to answer them. If you've got requests for objects to have a look at, last I checked outside, it was still cloudy here in Toronto, trying to clear, but still cloudy. But we've got a very large reservoir of archived images. So ask away, and the Observatory team will see what they can do. Our broadcast is powered by and is in partnership with Astronomy.fm, the voice of astronomy. If you've got any questions or comments you have on our past shows, or if you have suggestions for future topics, please send us an email, observe@yorku.ca. And please, by all means, follow us on Twitter @YorkUniverse. We will be monitoring the chat room for all those questions that you stumped the Observatory team for, and we'll bail them out. Good evening, Sarah and Shatish. How's life?
Life is good, as always. Busy with everything. Science and more science.
Science, more science, and soon that thing called writing of a thesis, right, for you?
Well, it depends on your definition of soon.
Okay, right. Not soon enough by the sounds of that answer.
Right.
Well, it's okay. It's coming. It is coming, that's for sure. But at least summer has been sort of trying to rear its head here. Although, of course, on the weekend, it was clear one day and rainy, cloudy the next. So it's been a very, very disappointing summer so far as straight out observing is concerned. But it's got to get better. Okay, Sarah, I'm going to hand it over to you, and you can introduce our guest.
Sure. So our guest tonight is Roxy Fournier. Roxy is currently a PhD student at the University of Toronto, researching the cellular mechanism of astronaut bone loss. Before that, she majored in biology and obtained a Bachelor of Science from University of Victoria in British Columbia. Last year, Roxy joined SEDS-Canada, which is Students for Exploration and Development of Space, as a volunteer staff member to manage the first Canadian Reduced Gravity Experiment Design Challenge, or in short, CAN-RGX, which is happening this year, July 24th to 28th, so just next week. After her doctoral degree, Roxy plans on continuing to do research in space life sciences, which she finds is the new and exciting field with many applications for upcoming human missions to the moon and Mars. So with that, welcome, Roxy.
Hi, Sarah. Thanks for inviting me.
Thanks for joining us. How's your night going?
Oh, it's been great. Just at the office here at U of T. So yeah, it's been a busy day, and with CAN-RGX coming up as well, it's been quite hectic.
Can imagine. Can you tell us a little bit more about CAN-RGX? What is it exactly?
Yeah, absolutely. So CAN-RGX is the first competition of its kind in Canada, which is really exciting. I mean, NASA has something similar. The European Space Agency also has something similar. It's essentially a competition designed for any student studying at a Canadian college or university. So that includes Canadian citizens or international students. And they put together a team and write a proposal for a small experiment to be tested on board a parabolic flight. And so the competition aspect of this project is that SEDS-Canada will select 4 teams to move on with their proposals and actually get to build the experiments that they proposed, and then followed by having a couple of students from the team actually fly on board the parabolic flight with their experiments to do the science. So it's a really, really great opportunity for students in Canada who are interested in being a part of the space industry.
That's amazing. How long is their flight experiment? How long would they actually be in flight for?
Well, a typical parabolic flight takes about an hour and a half. There's a little bit of transit time from the Ottawa airport out to the testing area. And then they do consecutive arcs, so parabola, that is. So that would be the microgravity portion. And that would last typically maybe about half an hour. And then fly back to Ottawa airport.
Have you ever been on one of these flights as a matter of interest, Roxy?
I have not, although I'm vying to get a seat on one of the flights that are happening next week.
Excellent, excellent. If you succeed, we're going to bring you back so you can tell us all about the experience.
Absolutely, I'd love to.
Sorry, Sarah, you were moving along there quite nicely, but I had to ask.
It is exciting, yeah. So who are the teams that are competing this year?
Oh, it was so hard to choose for. I will tell you, we got so many applicants, so much interest in Canada. So we have four teams, and so the first one being, let's start, I guess, from the West Coast. We have University of Alberta Team ISSE Lab, and this is a team that was built around a professor's lab. So there's a mix of undergraduate students and graduate students. And the next one would be the University of Saskatchewan, and their team name is Team Star Fox. And they're a part of a larger organization, student organization at U of S, University of Saskatchewan Space Design Team. And the next we have U of T's very own team, Team Avail. And they are based out of U of T St. George and UTIUS, which is the University of Toronto Institute of Aerospace. Yes.
Studies.
And then Aerospace Studies. Yes, that's right. And then the last one is Carleton University's Team COSM. Yeah, and they're all doing really, really cool projects. I don't know how much in depth you'd like me to go into their projects.
Is there a secret to reveal? Sorry.
Well, why don't you just tell us a little bit about the U of T entry, because I'm guessing that you're a part of that group?
I actually am not. So my role is more just as a mediator of sorts. I communicate between the teams, and we have great collaborators at the Canadian Space Agency and the National Research Council of Canada. So I pretty much just do all the logistical stuff. U of T's team, just because they're local, so Team Avail, yeah, I can tell you a little bit more about them. Yep. Their project is centered around a need to better understand how to 3D print in space. So 3D printing, basically you're liquefying plastic, typically. and turning them into 3D objects. But in a microgravity environment, fluids behave very, very differently. And so if we want to apply typical 3D printer technology on, say, the International Space Station, we have to understand how these fluid plastics behave. And so Team Avail, they selected some fluids that have similar properties to liquid plastic, and they're going to look at how it coils when it's released from a nozzle. And they're going to shoot the whole thing on a high-speed camera during the parabolic flight and observe the different coiling effects.
Goes to show how much we take for granted things like gravity here on the surface of the Earth, because, of course, everything falls down, and we've been modeling that type of behavior for a long time. But something as simple as monitoring a fluid, and as you say, rather important for 3D printing, fluids don't behave the way you would expect in a zero gravity environment. So something as simple as, let's look at a fluid, really has fairly dramatic implications for fabrications of materials in space.
Absolutely. And that's the beauty of this team's project, is it is very simple. When you get down to it, though, it's a complex problem, and it has so many applications. I'm hoping that they can put together some kind of publication in a peer-reviewed journal afterwards, which would be fantastic.
Well, that sort of leads me to the next question. These are experiments that will be sort of one-off, shall we say, inside the aircraft. What is there a longer-term goal? Not just for the winning entry, but as you say, there are 3 or 4 that are really good. Is there a thought that they may try to do this in a repeated fashion, upscale it to the International Space Station for something like a getaway special, to use the term from the shuttle era? What's the long-term plan here, if any?
Getaway special. I love it. We should integrate that.
I'm sure it's copywritten somewhere like.
Oh man, yeah, that's definitely on SEDS-Canada's radar for a long-term plan. We do plan on running this competition every year. In terms of the students, they're free to do as they wish with their research after the flight campaign. We certainly would hope that we can develop better relationships between SEDS-Canada and the CSA and the NRC, and perhaps get something going where we can have the teams eventually design their experiments for the ISS. I think that would be absolutely fantastic.
Well, it certainly strikes me as the obvious upshot, if you will, if the experiment goes quite successfully aboard the aircraft for the brief periods of microgravity, it would seem to me that the next step would be to explore it further with the nuances that will result from it in a more prolonged microgravity or zero gravity environment. So going up onto the International Space Station, none of these experiments sound as if they're terribly mass intensive, because that, of course, is always a big consideration in getting stuff up to ISS. But if it's modest in weight, it would seem to me that all of the experiments being proposed have got long-term positive implications, and therefore it would be a good plan for the CSA, for NASA, or even for any research team to be able to take what has happened here as a beginning and expound upon it in the ISS environment. Yeah,
and that's exactly what these parabolic flights are actually designed to do. A lot of technology that's been implemented on the ISS or in space have done preliminary tests first in parabolic flights. It's obviously a lot cheaper to run a parabolic flight campaign than it is to send something into space.
Well, yes, that's true. Sorry, Satish?
Oh, no, I was just about to ask, so when you say reduced gravity, is that not always zero gravity? And then what's the range?
Well, we can get, the plane is essentially in free fall for that microgravity portion. So it is the same as the ISS being in free fall around the Earth. So we can get to the same gravitational value as astronauts would experience. It's just that it's a very small portion of time. You would only get about 20 seconds of microgravity per parabola. But we can also, what's interesting is that these pilots that fly these parabolic flights, they're capable of tuning it to whatever gravitational amount that you need. So say you want to design something for lunar gravity or Martian gravity, they can tailor it to your specific needs.
It's all a matter of the flight path, Satish. How steep or not so steep that you want it, but regardless, the ground keeps rushing up towards you, so you've got to pull out of these dives, hence why you only get 20, 30 seconds worth of microgravity. But you do it repeatedly, and I think you said, Roxy, that there's about half an hour to an hour's worth of activity in this regard?
Yeah, and it also depends on the researchers on board. So if a team requires a little bit more setup time in between each parabola, then that will stretch it out, obviously, a little bit. Yes. And it can get quite nauseating if you're doing consecutive parabola one after another too. So it's good to have a little bit of a break.
Well, we do know what the aircraft is affectionately referred to as, don't we?
Yes, the vomit comets.
And that's a very true representation of it, Satish. Absolutely. It sounds all very, very exciting. Is this the first year? I'm not sure whether you said this was the first time that SEDS has run this competition.
The very first, yeah. The very first of its kind in Canada, regardless of SEDS-Canada's involvement.
Okay, fair enough then. But the expectation, the hope, is that it will become something of a regular competition.
Absolutely. Yeah, we hope to run it again next year and working on getting a long-term plan together.
Okay, sounds good. Sarah, did you have any last questions about this actual exercise? Because then I was going to ask Roxy a question about her research.
No, and more of a comment. It sounds super exciting, and I can't wait to hear more about it after the competition.
Yes, Sarah and I will both be in Ottawa next week. And yeah, I'm super, super excited about it. I think it's going to go really well. We've got a great team together, and the NRC and CSA have been just fabulous at helping us put this together.
So the flight is, in fact, I think you said there, the week of July 24th to 28th. Is that correct?
That's right, yeah, next week.
Right, so... Oh, yeah, my gosh, it is next week, isn't it? Where is the summer going? That's all I want to know. So maybe we should ask you back in August, and you can give us sort of a bit of a wrap of how it all went.
That
be up for that?
Great. Absolutely, yeah. Let's do it.
So I have a different question for you. Obviously, you're partway through your PhD, correct?
Hopefully partway, yeah.
No, I guarantee you're partway through it. What is it that you are researching?
Yeah, well, thanks for asking. So my research is also funded by the CSA, and we want to discover some more details about how bone cells behave in microgravity. So I'm using a completely different microgravity model than what we're just talking about, which is parabolic flight. Instead, I am putting individual little cells into a rotating dish, and now the cells are in constant free fall around this little dish, simulating microgravity. Now, my cells, as Sarah mentioned in the intro, I'm studying bone cells, and bone cells are actually really, really cool. We definitely take them for granted. So these cells, they live inside your bones, and they sense any type of force that you apply onto your bone. So say you're walking or running or just moving your arm, they will sense every movement, and they respond by building more bones. So, weight-bearing activities like running will build stronger bones versus astronauts, because they're in an environment where there's no gravity on the skeletal system, and so these cells they're not getting that input anymore. And hence, astronauts lose a lot of bone mass. They lose 1 to 2% of their total bone mass per month in space, which is it's actually quite a bit. And then they have to deal with other issues like increased blood calcium levels and all sorts of other things. So we need to deal with this problem. But we don't understand how these cells behave. And so that's what I'm looking at. I'm just looking very closely at cellular mechanisms and trying to figure out how we can potentially mitigate at the cellular level astronaut bone loss. So something that we could give to astronauts that would target these cells and stop this really dramatic bone loss.
So
Interesting.
the very act of being in gravity and movement is what causes these cells to make our bones or increase our bone sizes, as in bone size, sorry.
That's correct. Yeah.
Wow.
It's a problem that we've got to resolve, because obviously if we're going to start sending people to Mars, they're going to be in a zero-G environment in all likelihood for up to 9 months. And then we're asking them to survive on a surface which is, 1/3 Earth's gravity. So resolving this type of bone loss challenge is definitely high on, I would imagine, NASA's priority list.
Yes, definitely. I know NASA is doing some research similar to mine, but mine is a little bit more unique in the sense that I'm just studying the cells themselves.
Mm-hmm. Hey, there's ample room for all sorts of differing takes on the same problem, and it'll all come together, I'm sure.
Oh,
Fingers crossed that this all works very well for you in the coming couple of years.
Thank you. I'm really excited about this project. I hope it goes well and that it has lots of implications.
Well, I noticed that you're from my alma mater there at the University of Victoria, so your pedigree is absolutely excellent. I'm biased, of course, but what the heck.
I was going to comment on that, Paul. Yes, we do share an alma mater.
Quite true, quite true. Okay, we probably need to wrap this at this point. Satish, Sarah, any other last-minute questions for Roxy?
That'll be all. Thank you.
Yeah, thanks a lot for joining us. This is a lot of fun.
No, thank you guys. I had a blast, and it was great to talk about SEDS-Canada and CAN-RGX and my own research. Definitely invite me back anytime. I could talk for hours.
We'll bring you back in August so that you can tell us what will happen next week. I think that should be in the past tense. What did happen next week? That's a really strange sentence.
And that will be after your first, as in after her first flight, as we discussed.
Hopefully.
Yes, hopefully.
Okay.
I'm putting it out there in the world.
The universe will conspire. Yeah.
Well, good luck, Roxy, and thanks again.
Thank you very much, Paul and Sarah and Satish.
Pleasure.
I'll talk to you guys again.
In August.
Sure. Okay.
Thanks.